Share my screen. All right. Welcome guys to the next PCB workshop. This is the third PCB workshop of the whole series. Last time we left off here with the actual footprints, the components that we are going to lay out for the name tag we're creating. Um, I I looked online to see like what kind of like basic dimensions of like a name card are, and most of them were about like two by 3 inches, which was a pretty reasonable amount. So this is how big the name card's going to be, and then these are the components we're going to lay out. Before we start moving everything, something that's really important to consider is if you click on this green button right here with the little cog here, you can pull up a bunch of stuff about your board. I think I went over this a little bit in our last meeting, but you can see like how many layers you have, what each layer consists of. I think you can you can't change that. Okay. You can specify like what kind of dielectric you're gonna have. FR4 is the most common, which is usually made of fiberglass. But the thing we really care about here is the constraints and these net classes. So if it really depends on what your goal is when you finish the PCB. If you plan on sending it to a manufacturer, then I really recommend going to look at the manufacturer's website. So in this case, I have JLC PCB. This is one of many manufacturers you could go through to print out your circuit boards. You can print in a variety of colors, but green, of course, has the fastest production time. Any other color is going to add 2 weeks to your manufacturing. So that's not worth it depending on your use. But they tell you everything that they are capable of doing. So they can do 1 layer, 2 layer, 4 layer, 6 layer boards. What kind of materials they have. They have a lot of specifics, but really, and max dimensions as well. That's important to consider. What kind of tolerances they have. So if you need something really specific, if it has to be exactly 400 millimeters, then you might have some issues because, well, it might be 399.8 millimeters. But the main things we want here are just like what kind of drill hole sizes they can do. So they can do anything from 0.2 to 6.3 millimeters. So we can go and check here, and we can make sure in our design rules that we had diameter, hole clearance, annular width. Here it is. Oh, that's for micro vias. But they don't have one for, okay, that's interesting. Huh. Oh, there it is. Okay, I thought that was the edge of those circles. So I can set this. And if you want this in different units, so right now it's all in inches because I have inches selected here on the left. In the website, they have it in millimeters. So I don't think, yeah, okay. So I have to close it, go into millimeters, click it. And then here, minimum through hole 0.3 millimeters, and the smallest they have is 0.2. So we can set that minimum through hole 0.2 millimeters. Drill hole size tolerance, that's okay. They don't do any blind vias. So blind vias, when you have multiple layers, those are just vias within the sandwiches of the board. So if you have a top layer and a bottom layer, the 2 layers in the middle, you can't have any vias between those 2 sandwich layers. That's what a blind via is when you drill a hole from one layer to the other. And it doesn't go all the way through from front to back. So we call those blind vias. Minimum via hole size 0.2, minimum diameter is 0.4. That would be here. Yep, 0.4. Okay, pad size. Okay. So these are worth considering because when you start picking out your components, the design rule checker, when you have all the components out, will say like, oh, hey, this component you picked has pads that are way too close. And if you plan on going to this manufacturer, they're not going to be able to make that spot for where the component's going to go accurately or at all. Sometimes they'll just reject your design altogether because their equipment isn't capable of getting pads or through holes or anything too close. Sure. Oh, uh, oh, okay, sure. Um, so the first thing to check, we did this in the last video, but I'll review it again. The first thing to make sure is that if you go to preferences, go to manage footprint libraries. And if you scroll down to, it might be at the bottom. Yeah, scroll all the way to the bottom. Do you have this DigiKey footprints here in the libraries? Okay. So then I want you to click on this folder symbol here. And then I'm not sure where you saved it on your computer. For me, I have it wherever your DigiKey library that we saved way back at the beginning. You're gonna go to I put it in imported libraries, DigiKey. You're gonna collect a bunch of footprints over time. So I try and organize this. DigiKey and then DigiKey library master. And then what you want is this DigiKey footprints.pretty. There's no folders in it. You don't, or files in it. You don't have to select anything inside it. For the footprints, you just need to select the folder. Yeah. Let me know when if you find it. Okay. Sure. Oh, I see your problem. Okay. Cancel this. Close this. So your issue is you're still in the schematic view here. Okay. So we need the you didn't place any of the components or anything from okay. You're gonna have to do that. So in the first two sessions, we made this schematic here. You're gonna have to put this together. Okay. You can't move on from this point until you put that together. Yeah. Uh, if but if you want to make sure you have the libraries imported, I can show you how to do that really quick so that you can once you make the schematic, you can move forward in the process and not have the issue of, oh, my, where are my footprints? Or so when you're in the schematic view and you go to manage symbol libraries, when you go down to the all the way at the bottom, do you see all these DK libraries here? So the DK is for DigiKey. That's they had a bunch of useful libraries for extra components that you may have to. Okay, so then click on this folder. I want you to go to where the DigiKey library is. Go to DigiKey symbols. Okay, you should be able to click this drop down, and then we just want the .lib or yeah .lib files. Okay, and then I want you to click on this white box here to select all of them, and then I want you to click open. I already have these imported, so I'm gonna click cancel. But once you click open, these should all show up at the bottom. So what this does for you is now when I go to add components, I can go down to these DigiKey libraries and they'll have these components already pre-made for you. So that's why it's important to know how to import libraries, because oftentimes you won't want to make these by hand. You'll want to see, oh, is it already made online? And then you can download it, usually for free. You just have to make a free account, and then you can import the library. You do need to make the whole schematic because each of these symbols have a footprint associated with them. And then we went through and we picked all the footprints for all the components. So these are all the actual physical components I'm going to use. And then we went back to here, and if you click on PCB editor, it'll open this page. And then you click on update PCB with changes, and it'll throw in all the footprints you selected for each component. So here's where my battery is going to go. Here's my 555 timer. A couple of my electrolytic capacitors are here. Here's my transistor and everything else. Okay. Um, so that's why I'm saying you have to go back and fill that out. Okay. Um, okay. So the design rules. If we pick up where we left off earlier, Um, you just want to make sure you already have all the design rules from your manufacturer selected, because it'll make your life a lot easier. A lot of these are usually like reasonable or within a manufacturer's capabilities. Another thing to keep in mind is micro vias. Not all manufacturers can do micro vias. Micro vias are the same thing as normal vias. They're just a lot smaller. Um, so it's if you have a lot of like if your board is really squeezed in or you have a lot of parts on your board, you can use micro vias instead if your manufacturer supports that. Okay. So the first thing I usually personally I'll make the cutout of the board first so that I know what I'm working with. So the first thing you're going to do is you're going to click this drop down, and that's going to tell the software, okay, what layer am I looking at? If you want to work on the board, you're going to want to go to edge cuts. This is what's going to tell the manufacturer and the software, hey, this is the edge of my PCB. And luckily, they have a nice feature now. You can click on this draw rectangle. I'm going to click once, and it'll show me how big of a square I'm making. I'm actually going to switch the inches really quick too. And I'm going to change the grid size 1 inch. There we go. Now when I go to square, I'll be able to get exactly a 2 by 3 inch edge cut like that. I usually like to, just in case, like if you forget or if you're coming back to it, I'll go to user comments. Another tool you can use is right here, add and align linear dimension. So I can go to one corner and then the other, and then you can kind of just like place it wherever you want, and it'll show that dimension now permanently. So 2 by 3 inches. And then any other comments, like you can add little text boxes, make sure it's on the user comment layer. You don't, unless you're drawing anything with like copper or silk screen, you want to stay in the user comments. That's just for like anybody who's looking at the software or your board to understand. The user comments are the help, and usually they're just showing the dimensions, or if you have antennas that are going to be on your PCB, it'll show like, okay, this is a zone. Don't put any copper traces in this zone. All right, I'm going to change my grid size back to a more reasonable size. And then we're going to start aligning all the components on our name tag. So I have a pre-made type of layout I'm already gonna follow, but you can you can really wire this in, or well, you can organize it in like any way you want, but since this is a name tag, I'm gonna leave a considerable space at the top of my PCB to put a large silk screen on the front, and that's what's gonna allow us to write our names on the PCB. It'll act a lot like a marker board. So let me just put that up. Right, and then at this point, you would just start organizing your board. Um, the only thing you really have to make sure is none of the pins are too close, or pads, I'm sorry, are too close to each other. That's also according to your manufacturer. So let's see, should have another one somewhere. Clearance here. So the whole clearance has to be at least 0.5 millimeters. Pads must be 0.127 millimeters, and the via clearance must be 0.254 millimeters. Let's go ahead and actually make sure we have those. So minimum clearance, we want that in millimeters. Millimeters. I wish I could change that while I was in that menu. That would be nice. So minimum clearance. So this is between traces. So let's go see, add the track, tracing. So we're creating a 2-layer board, copper on the front, copper in the back. So the minimum trace width and minimum trace spacing is 0.127 millimeters for us. If you're doing 4 to 6 layers, or you're using more copper in your traces, these are the different minimum trace widths and spacing. So I'm gonna go ahead and put that in. 127 spacing. 127 and okay. And so then later on, when we use the design rule check here, when we're finished with our board, we can run this and it'll tell us, hey, you have this too close, or hey, this isn't connected. For us, everything is unconnected still. So of course we have all those errors. I'm gonna delete all those markers. And I'm gonna continue organizing all the components. These white lines, it's usually referred to as a rat's nest because when you import all your components, there's usually a lot of connections you have to make, so it literally looks like a mess of dashed lines. If you want to turn those off, you can click this here, or if you want curved rat's nest lines, you can. That's a new option you have. It's just to help you when you eventually have to make your connections. So it can help you also with deciding where you're going to place components. A lot of these lines, they can connect to a variety of things. So you're going to get lines that are going to disappear and reappear based on where you have the component placed, because the lines are going to show the shortest connection path possible. The blue LEDs we're going to have on the 4 corners of the silk screen. And that's what's going to light up and dim around the silk screen. So these 4 LEDs are going to go right here. If any of you guys aren't exactly sure how you want to organize your components, I'll have a finalized version of this by the next workshop, by next week. And so we can check that out too if you'd like. Hello. We just started creating the layout for the PCB. Yes. So we left off after we imported the PCB. Now we're just kind of like arranging components. I already have a ideal layout, so I'm trying to do that right now. Um, but you can lay it out really any way you want. Just make sure you have space to make a silkscreen layer where you can write your name. Okay. Um, I'll also eventually add the IEEE logo to this too, but we'll do that in another workshop. Delete this now too. I decided to have a name tag that's going to be 2 by 3 inches, but you can make it any size you want. Um, that's really up to you. Another thing to keep in mind that although all these all these through hole parts are going to have a certain minimum distance, but another thing you can't do is there's this purple outline on every component that's called a courtyard. You cannot have the courtyards of your components overlap at all. If you want to get it like extremely close, then you can pick the smallest grid size. You can zoom in a little bit here and move your component. It's not what I want. Now I can try and get it as close as I can without overlapping. So even this might still be overlapping. Yeah, see, that's still overlapping. So I have to go one more over that way. That's like as close as I can get it. You can also make like a custom grid size um, to get that extra fraction of an inch. Um, you would just go to edit, use your grid, and then you can pick and set all your values here. Um, darn, I forget what grid size I was on. I think I was. Uh, okay. Another useful feature, once you have all your resistors placed, right? Say they're all kind of like shifted, like in a weird way. I can select multiple resistors like this by holding the shift key and then clicking on all of them. And then I can right click. I can go to align/distribute. And currently we have them aligned horizontally. So I can click that and it should space them out even. But then there we go. Okay. So align to vertical center here. So that lined them all up so that they're all equal to each other, like top and bottom. And then when you click on the distribute horizontally, that will make sure all 4 of these resistors are equally spaced. I actually have more resistors. Let's go ahead and put them all next to each other. Don't worry about the silk screens. They're all like overlapping with each other. That's what the reference number and the 330 ohm here. That's a silk screen. It's okay that all these are overlapping. We're going to move those later so that they'll be visible on the final circuit board. Not going to be able to fit all of these, but let's see how many we can. Definitely. So that's the edge right here. So I got 5 lined up here. So I'll take these two. I'll just throw them right. Tribute and okay. And then you can organize it, really make it your own. Try and align it in a certain way that you want. You can do whatever you want. Um, just try and keep an eye on the rat's nest connections, because that's gonna decide how easy or hard it is to line up your board. Another thing is, if any of these layers are kind of like bothering you, like this drawing text that is associated with the footprint or like the comments, you can come to the layers side here and I can turn off user comments. So now it's not deleted, it's just I can't see it. And that can help sometimes with just organizing your board a little bit. Front fab is what these symbols are. They're just associated with the footprint to tell you what it is or help explain what it is. I'll turn those off, and now it's a little bit cleaner and easier to read. Resistor here. Okay, so then once you have all your components laid out, just kind of move them around and keep an eye on, like I said, the rat's nest lines to see if there's any better ways you can orient the board to make the connection easier, because eventually we're gonna have to make connections to all our components like that. And then you'll see that the white lines disappear, right? Sometimes I'll have to go around in a weird route. Don't worry about putting silkscreen over the copper traces. That's not um, that you used to not be able to put silkscreen on top of the copper, but nowadays it doesn't matter. The fact most manufacturers will be able to do that. Say I laid out my whole board. Say I had all my connections. A very convenient way to delete all your connections is to go to Edit, and then you can go to this Global Deletions, and then I can select Tracks and Vias, and that'll delete all the copper that I laid out, which was just those 3 connections. So I'm still messing with the layout here. Then I can even align these two and make sure that they're lined up, and then I can move both of them. Just things that make your board look more symmetrical. So you're gonna go up here in the top. You're gonna select edge cuts. Edge cuts. So that edge cuts refers to the actual cutout of the board. It used to be that you had to draw a line from each side and then make sure they were perfectly horizontal or vertical, but now it's super easy. Mine's gonna be 2 by 3 inches, my name card. So a really easy way to do that is you're gonna go to inches for your units, set a grid size of 1 inch, and now it'll be like really super easy. I can click on this square, or they call it rectangle actually. You just pick a place to start, you can click, and then that's 1, 2 inches, and then 1, 2, 3 inches. Yep. And then once you click, there's your edge cut. Yep. Keep in mind, guys, for the electrolytic capacitors, it is really important that you make sure that when you're manufacturing or when you're soldering it in yourself, make sure you have the right polarity because you could ruin your capacitors. They could blow up in your face and don't want anybody getting hurt. You need another useful thing when you do eventually start making your copper traces is it'll highlight all the connections you have to make with that one trace. And sometimes that can be useful for deciding how to make your connections. Remember that when you start making your traces, you cannot overlap any other trace on the same layer. So for this connection, I would have to go all the way around that connection. So this might not be the best choice. Or another option is you can go to the back copper and then I can make the connection from the back side. And you can do this with all the other connections as well. I highly recommend doing your ground last. Do the connections that are most important, like any signals that have to go about your board. Do those first. Then you can make all the other necessary connections, small signal or just power, and then do your ground because what you can do is if you're able to keep it all to the one layer on the front layer, then what you can do is you can make the back layer all like a copper ground plane. And then instead of making this ground connection all the way from here to here, I can just create a via. So I'll show you. Or I wouldn't even need a via actually, because this is a through hole, not pads. So because the pad is made on the front and the back of the board, um, it would already be connected to the plane. So if I wanted to create what I just said, then I would go to, actually, it doesn't matter what layer you're in. You would click on this add a filled zone. Might be useful to be in the inches because I'm going to do the entire board. So add filled zone. I want it to be the back copper. It's going to be the ground connection. You can set other parameters like clearance and minimum width. And then there's some different ways you can have it display once you have it placed just to make it visually easier to see the rest of your components. I'll mess around with that after we make it. So you would click OK, and now it's gonna have this line that you can track from where you clicked initially. So I'm just gonna outline the entire board back here, and there we go. So now I have an entire ground plane on the back of the board. Now, when you click B, it will fill in that entire zone. So the entire back of that board is now covered in copper, and you're gonna have this minimum clearance here. So I believe it was set to 0.2 millimeters. So there's gonna be the copper is gonna be removed near the edge of the board there. You can change that if you'd like. It's up to you. Another option to consider when you're making your zones. Click the zone, click E. Then you can look at all your options again. Oh, so 0.02 inches. That's the clearance. Right here, this is something else that's important to consider. You can make a solid ground connection, or you can have thermal reliefs or reliefs for all your through hole components. Thermal reliefs, they're mainly just to make it easier for you to solder your components on. When you finally start putting your components on the board, it helps so that if you had a solid layer of copper instead of these thermal reliefs, then when you put the soldering iron onto the pad, it might take a while to heat up because all the heat is dissipating to the whole copper layer you just created. So these thermal reliefs will help focus the heat on the pad so you can melt the solder onto the pad and get a good connection with your component and the board. So that's something to consider. So all my ground connections are going to have thermal reliefs there. Say I wanted to make a connection though now. So if I went to the back copper here and I want to make this connection on the back layer, you're going to have to refill the copper on the back. It's okay. I mean, you can do this. You can have this copper trace here, but now when I click B, you'll see it'll remove the copper where I made the track so that it's not a short circuit. Okay. I'm going to try and keep them all to the front side of the board, all the connections. So let me just really quickly make sure this is the final layout I want. And it's okay, like even if I move components, like it's still going to be there. If you click B again, it'll redo it. Or you can Control Z, put things back. See, like this, the line crossing, that might be a difficult connection. And since one is on this side and the other's on the other side here, it might just be easier if I just flip that. See, and now it'll be a much easier connection from here to there. Same thing with this. You want to try and make it, ideally, you want none of these rat's nest lines overlapping each other. Okay, so that looks good. Some of these you're not going to be able to have them not overlap. That's okay. You're going to have to mess around with your, how you wire all the tracks. What I'm talking about is like this one right here. These two lines cross, the rat's nest lines. So it would obviously be easier to rotate this. And then the one connection that has to go up that way and the one connection going down this way will be easier to connect. Okay. think think this is the best I'm gonna get right now. If I make any changes to this, I'll let you guys know. Um, if you notice too, because we put since we have the ground plane here now, none of these ground connections have rat nest lines. That's because they're all already automatically connected to the zone. through the thermal reliefs. So now I can start. Okay, I don't know. Maybe I'll come back to making the connections. We can do the connections next week because I want to try and organize it a little bit more, but that's going to take a lot of time and you guys don't want to hear me lecture all the time, right? So, what else can we cover? So how about we cover this? So the silk screen here, that's this yellow layer. You'll eventually want to organize these all in a way that you can view them all. So like this one, you can see the pink line. See the pink line right there? It's associated with this resistor. So try and line up all your silk screens so that they're next to the component that they're referring to. There's R5, there's R7 here, R9. Okay, and this is just so that when you actually finally have your circuit board and you're looking at it, so you know, oh, this is resistor 9, this is resistor 7, because you're gonna have to look at the schematic and compare, like, okay, I'm putting the right component here. This is where the 100 kilo ohm goes. This is where the 10 kilo ohm goes. Okay. Here's the switch. You'll learn what all the different symbols mean, and then there's even custom symbols like this one for battery. But in general, D is diodes, S is switches, R is resistors, C for capacitors, and Q for transistors. And then there's a couple of fancy ones. U is usually used for chips, any integrated chips. U1 will go here. Okay. All right. Let's go ahead and add the silk screen as well. So we're gonna have a large silk screen here for the name. So I'm gonna go to the silk screen layer. I'm gonna want it on the front of the board. And then I'm going to go to the square again. And I want to try and get it exact. So I'm going to zoom in to the little circles here. I'm going to create a square. Okay. I'll mess with the LEDs a bit too. Shape. There we go. So if you click on E, you can click on filled shape and that will fill in the entire square. So now we have this nice silk screen layer. That's what we're actually going to write in permanent marker to put our name on the name tag. And then I currently don't have the IEEE logo right now, but I'll show you guys one of the methods I found for importing logos. So you can make custom logos, you can turn them into bitmaps, and then you can import them as a footprint into KiCad. But we're actually not going to use it as like a component. Instead, we're going to go to the silk screen layer, and then we're going to add that footprint, and it'll be all silk screen, basically. So footprints aren't just for electrical components, it can also be for other things like the FCC logo or the CE logo, any safety standards, or if you want to put like the electrostatic discharge warning, you can do that too. I think if you click A, it'll load up all your footprint libraries. And then I believe KiCad has one. Yeah, so you can add all these logos and they have different size logos here. FCC. I think this is Oshpark, which is another manufacturer. All these you can add KiCad if you want. But I'm going to show you guys how to import the IEEE logo. And that's what we're going to add on here as well. All right. Yeah, so just make sure you're on the front silkscreen layer, and then you can go down to this add a text item, click that, and it'll say silkscreen layer, say this is my PCB, click OK, and then it'll let you place it somewhere on the board. So for example, on my senior design, I have like my name on the board, designed by me. So, you can add anything you want. You can also do rounded edges. Um, so for example, I want to go to edge cut, and I can create little corners like this. I'll do one this way, and then I can do one starting here. And there. So I can create that, and then I can go to the line here. That, that. Try and line it up. So this is useful because now if I want like a lanyard, I now made a edge cut in the board, so they'll cut this part of the board out too. So we'll be able to put a lanyard or a capo through it, and we'll be able to wear it. Make sure you're in the edge cut layer when you do that, and then you can line it up and make it symmetrical and stuff too. Kind of hard to see, so I'm control clicking, so I'm clicking one, and then I'm holding control, and then I'm click. Be careful that you actually click the silk screen, because there's another option. If you want to see like all the connections you have to make without clicking on the trace, you can hold control and you can click the pad, and it'll highlight all the components. And then to undo that, just keep holding control and click the pad again. So that's another useful way to help lay out your board. Um, I think I'll end it here for now. This is what we have so far. I'm gonna work on this a little bit, and I'll review all the changes I make on the next PCB design workshop. But I'm just gonna make this a little bit more symmetrical, maybe a little bit bigger. I need to make sure it's wide enough to actually get a capo through it too. Um, and then I'll move a couple more of these components around. But I think this is all we're gonna cover for now. I'll continue recording, so by request, I was asked to record both of the sessions. So this is the end of the first PCB workshop session for today. So I'll let you guys go. Um, do you need any catching up? I can help you. Um, well, I'm gonna mess around with it a bit. Um, yeah. At least have the board and the zone, the copper zone in the back. If you want to come up here, I can help you if you want. Yeah, no problem, Patch. Yeah, eventually I will. Yeah. I'll also be printing a couple of boards here too, though, so you can see how the milling machine over there works. It only does 2-layer boards. So if you have anything that's more than 2 layers, it won't be able to do it. Um, I don't believe it can do silkscreen. It's very bare bones. It just cuts out the copper for you. It doesn't even put insulation over it, so it's all uninsulated. So way better. Yeah, less than $2. But if you want the components on it already, then it costs money. So if you want, yeah, there's a couple more steps which we'll talk about. You'll have to create a bill of materials, and you're not gonna want to use, if possible, you don't want to use any through hole components. You want, yeah. Well, so the way they do is they have a what's called a pick and place machine, and they have all the reels of surface mount components, and so they just stamp it onto the board, and then they put paste on it. Um, put it through an oven, yeah. So the more surface mount you have, the cheaper it'll be, the faster your board will be produced. You can also exclude things like if you have to have through hole components, but you don't want them to put it on there, then you would just keep it from the bill of materials. You wouldn't put it on your BOM. You would just send all the surface mount components on the BOM, and then they'll place all that for you, and then you can solder the through hole components yourself. That's I believe so, but it'll cost a lot more because of labor. Somebody physically has to do it. You know how much? The so whatever you pick out from the manufacturer will decide the cost as far as like components. It'll cost about like it's gonna be one of your big expenses is gonna be shipping. The JLC's from China, so that's gonna be like $30 in shipping. That's where they make most of their money. The size of your board is the next consideration, and then what kind of components you have. I'm trying to think off the top of my head any other things that make it more expensive. A lot of ICs in general are either out of stock or absurdly expensive now. It's like anywhere from $6 to $5. I mean, one of the inductors I had on my senior design was just 15 microhenries, and it was $4 just for that one inductor. But it all adds up really quick. For my board personally, it's about well, right, yeah. But the blank board is dirt cheap. It's when you actually put the components on. Now you're looking at about, for me, with a bill of materials of about 50 items on the board, it was about $150 for two boards with components on it. Yeah, yeah. Um, I would appreciate it if you continue to keep registering just so that I see it on my side. You can still attend. I'm not going to stop anybody from attending, but okay. Okay. All right. Thank you. Have a great day. Yep. Okay. Oh yeah. Okay. So to add the backside, here, I'll go ahead and delete this. So all you're gonna do is you're gonna click on oh right here, add a filled zone. Okay. And then let's see. So you don't even have to change the grid size. I was doing it because it just made my life easier. But if you move around, you should see a little circle pop up. That's how you know you're touching the corner of the edge cut. Good. I'll show you that. Well, try holding control. You zoom in a little bit more. Hello. It's not snapping to the corner. Okay. Well, it doesn't have to be exact, but I mean, I guess that's good enough. All right. Well, now I'm having trouble. Okay, hold on. Oh, I wonder, is it because of that? There we go. Okay, I see the problem. So make sure you're on front or back copper. Then click a zone somewhere relatively close to that corner. It doesn't have to be exact or perfect. Yeah, there you go. So these are the right options you want. We want it on the back copper, and it's going to be a ground plane. So we're covering the entire board, so it's called a ground plane. Yeah. So, and then you can change like clearances if you want to. You can select thermal reliefs or solid copper. You can decide what kind of like, this is just how like it displays it to you. So some of these might be more pleasant to the eye for you. So then you're just gonna click OK. You're gonna have this little line that sticks out. And now you're just gonna go to all four corners of the board. And once you, yep. And then so now you have that zone. And so this is that so what I was trying to show you, you don't have to do this, but you can change how it looks. So oh, well, now it filled. It autofilled. Huh, that's interesting. Okay. I'm not sure why I did it. But okay, so every time you move this zone, or when you move a component, that solid layer is gonna disappear. Okay. In order to refill that, just click the B button here. Just click B, and it'll refill all the copper for you. So you can notice that the back copper doesn't, there's no short circuits here. It leaves space for all those components. And then everything that is the ground has the thermal relief connections, all the pads already. So we actually won't have to make any ground connections at all because it's already connected via the copper layer. If you move a component or something, um, it won't line up anymore. If that's where you want to put it, then just make sure you click B again and it'll refill all the copper. If you don't do that, then you might see some errors pop up uh, later on. Okay. All right. And then here's our, yeah, and you can see here, you can see this earlier, but it'll avoid putting copper wherever there is no edge cut. This is going to be a hole, right? Yeah, so I went to edge cuts, and then I made the line connections, and then I made the round ones here, and I can move this as well. Here, it's like if I wanted to extend this, I can do that. I can do that, and then again, I have to refill the copper, and it'll fix it. So you're gonna change your layer to the front silk screen, not back. You want front silk screen, and then you're gonna click on the little rectangle here, and then you would do this on your board, but you would create a rectangular square like that. Then once you've created it, click E, and you could click filled shape, and then click OK, and it'll fill the whole thing for you. So this will be a solid layer silk screen. That's what we're going to use to write our names. Yep. You can. All right. All right. Yeah. Take it easy. See you later. Have a great day, guys. Oh, nice. That's good. Did you run any problem? Run any problems in the program? Perfect. Okay. That's really good. That's nice. All right. Really quickly, I want if you guys could scan this QR code to sign in. That would be really nice. Faculty really wants me to keep track of how many students are attending these workshops, so this would just help me keep track of those students. Because of course you can register for the event, but they might not necessarily show up. So yeah, let me zoom in. Right, right. Yeah, yeah. Well, they registered. So yeah, I definitely understand. Um, yeah, yeah, and don't forget, guys, I'm posting this on YouTube, so all you guys can view this even after this semester. You can watch it over spring break or summer break, next summer break. So, all right. You guys need any help with catching up? Um, okay. That's good. When you guys have something selected, whenever you click anything, it'll be stuck to your mouse, and then to get rid of it, just click escape, and you're back to the normal. Oh, you might not even register. Yeah, I don't think. No, I, to be honest, I can't even mostly see that. So, no, I will definitely. Okay. Uh, this is the third so far. Oh yeah, I was thinking about doing that. I was gonna make a little business card. Did you use Surface Mount? Oh, yes. Yeah, that makes sense. So these big bulging LEDs out of the board. The only thing is it gets really expensive. I Yeah, Patrick showed up too. Yep. He has a senior design for the project related to. I think Tan's having everyone do PCB design now because I'm doing this workshop. So I don't know exactly what it is, but he showed me like a schematic of something he has to make. Yeah, yeah. I think we're all pretty busy. Yes. Yeah. Another cool thing you guys will be able to do once you have this made, we'll be able to go to 3D viewer and we'll be able to see what our board looks like. Now we're gonna use blue LEDs, but KiCad it only has the red LED models, I think. So, for these components that don't have footprints, we can actually go to these and we can find 3D models for them. Battery. So I honestly, oftentimes I'm playing the guessing game of these, but if you know your exact component, you can pick it. Okay, so we have, you can also pay attention to the names here. Sometimes that will help. So BS-7. So actually surprised. So we go to battery 3D shapes here. Just kind of look through. So sometimes you will have to edit what this looks like. So what you can do is you can, yeah, sorry. All right, yeah, just make sure everybody's all set up. In this model. I think this is the best we're gonna get, but this is similar to the model type we're gonna use. Something like this that will hold the battery here. Then here we're gonna have to assign our 555 chip. And I really recommend these 3D models are just for visual, just for looks, but I really recommend doing it because it can help you realize, oh, the pitch is off in my design, or this chip isn't gonna fit where these where I place this footprint. Because so currently we're just making a name tag. It's gonna have glowing blue LEDs, and then we're gonna be able to write our name onto the board. I'm gonna put the IEEE logo on it as well. I will get you through this. Just go ahead and get everything set up, and I'll walk you guys through it. Okay. Where's the dip? Oh, there it is. Oh, wow, I didn't know that. See, this is an example where you would realize that, hey, this 10.16 millimeter width ain't gonna cut it. So good to look over. There we go. That's and now if we want, we can also But oh, I know what you're talking about. It was local. It was farther away. All right, so currently we're just waiting for some of the other students to get set up. So just bear with me. Yeah, it was really hard. Yeah. What's all the digital libraries? Yep. Oh, you're right now. Yes. Yeah. So. As far as like. When you're. Yeah. Oh, yep. Are you guys all ready? Yeah. Okay. So we left off, I know I just went through the first workshop, but we had all our components laid out on the board or on nothing. All right. Correct. Yeah. Yeah. So you could, I'm gonna leave it up to you guys. You can lay it out however you want. Just make sure you leave space somewhere to make this large silk screen, so that you can write your name on the name tag. Okay. So the very first thing you're gonna do, is you're actually gonna click on this button for Edit Board Setup. And this is a part that a lot of people skip. But I really recommend it to go to the design rules and constraints. And I already have everything put in. Um, you know what? Before you do that, change to millimeters. If you click the units on the left here, it'll change. Yeah, I'm sorry. You have to close the window. I just told you to open it. Click on millimeters and that'll change all the units here to millimeters. And the reason I'm saying to do that is the very first thing you need to consider before you start making your board is am I gonna have it manufactured by someone or am I gonna well really actually you know for any time you need to think about the manufacturing process if you plan on actually making your board. Because there's going to be some things that the manufacturer isn't capable of because their machinery isn't precise enough or good enough. Okay, so you're going to want to go to a PCB manufacturer such as JLC PCB. There's a ton of different ones. You don't have to go through JLC PCB, but that's who we're going to go through. Okay, maybe. You usually pay the most out of shipping. This board is going to cost less than $2. Components are going to be like maybe $20, and then shipping's going to be another $25 each board. Right? Yeah. Well, I'm going to buy the boards in bulk, so I only have to pay one shipping cost, and then I just pay for components. So, um, here's the materials. This manufacturer is capable of using, so they just have FR4, which is a standard usually. They can do one layer, meaning just copper at the top. They could do 2 layer, 4 layer, 6 layer. Um, Double-sided PCBs. You can, if you need this for whatever reason, they have the dielectric constant, maximum dimension sizes. Um, if your PCB is really big, that's going to be the main part of your cost because the way these manufacturers make these people's boards is they take in a bunch of orders, then they have these huge sheets of copper clad PCB already, and they put the one whole board through the machine and they have a bunch of people's different designs on that one sheet so that they can print out multiple of people's boards at the same time. So the more real estate your board takes up, the less boards they can make for other people, and they're losing money. So you're going to pay that cost. Okay. So you want to always minimize the size of your PCB as much as you possibly can. The main reason I wanted to come to this page here, though, if you don't have it, just look up jlcpcb.com. This was actually the first page it brought me to. But if you can't find it, it's jlcpcb.com/capabilities/PCB-capabilities. Another thing to note is you can do these different color PCBs, but they're going to add 2 weeks of manufacturing time on your boards, unless you use green. So green is the default. But the main reason I wanted this is because they have minimum drill hole sizes right here. So like it has to be at least 0.2 millimeters. You have minimum via hole sizes, also 0.2 millimeters. So what we can do is we can take these parameters and I could say, okay, minimum 0.2 millimeter drill hole size. So I can go back to here into my constraints and I can find drill hole size. Okay, so it's not in here. Minimum via diameter, minimum through hole. So here's the through holes. Silkscreen, micro vias. Okay, I'm sorry, they don't have the drill hole constraint, but they do have so minimum via hole size is 0.2 millimeters. So this is how big your via can be, or how well the minimum size for it. It can be bigger than 0.2 millimeters, but it has to be at least like if you're trying to get usually you're trying to get the smallest via possible so you can fit more stuff on your board. So 0.2 millimeters is as small as you can go. So you can set in holes minimum through hole 0.2 millimeters. You can set hole to hole clearances. So somewhere in here they're gonna have right here. So from hole to hole clearance, it must be 0.5 millimeters. So if I go back to KiCad, yep. So I'm not sure. Okay, so the way it has it pictured, it looks like edge to edge rather than hole. Oh no, it says hole to hole clearance, so that should be right. So 0.5 millimeters right there. So hole to hole clearance. So the keyword there is it tells you hole to hole clearance, and then here it says hole to hole clearance 0.5 millimeters. So if we did not do that, if we would have made our whole board, then all our vias would have been at minimum 0.25 millimeters close to each other. That would have been a problem because they're not capable of doing that. It has to be at least 0.5 millimeters apart from each other. Okay. So that's the whole reason we're doing this is because then the software will physically not let you do anything wrong. It won't let you put any of the components too close. Um, the only other important thing I noticed was they have down here for 1 to 2 layer boards, there's a minimum trace width and minimum spacing. They're both 0.127 millimeters or 5 mils. So I changed both minimum clearance and minimum track width to 0.127 millimeters. So you're also able to do this in net classes. So I can change all these clearances and track widths and via sizes, but automatically these constraints override everything. If you disobey any of these constraints, you're gonna get an error. Okay. So that's why I think this is much more useful. So I don't have to define a class or redefine my defaults. So it just makes your life a little bit easier. Once you've done that, we can then start actually making our PCB. So the first thing you're going to want to do is you're going to want to click this drop down here, and you're going to click on edge cuts right here, about in the middle. Okay. Once you click edge cuts, you used to have to draw a line from just like in general, and then you had to look at your coordinates and figure out, okay, this is perfectly horizontal or perfectly vertical. But those days are long gone. You don't have to do that anymore. I decided I'm gonna make a 2 by 3 inch board, so I can set my grid size to 1 inch. 1 inch. So now my grid will only let me go 1 inch apart from each other. And I'm in edge cuts, so I'm going to click on draw a rectangle. And now it will make it really easy to draw a 2 by 3 millimeter board, which is 50.8 by 76.2 millimeters. You can change the units back and forth and everything. So then once I click again, there's my PCB. Then I'm going to go back to a smaller grid size. And then I really, really recommend click here again, go to user comments on the drop down after you make your PCB. Oh, sure. Okay, so you click on the rectangle and then you just pick a corner and click. And then once you start moving, you don't have to click and hold, you just click and then you click again to finish the rectangle. Here. It's 50.8 by 76.2 millimeters. I'm going to show you how to add those comments I did in but so it's useful sometimes to other people, or if you're still working on your design, to add the dimensions to your board. So if you click on add in aligned linear dimension, you can go to one of the corners here, and it snaps on for me, but some other students, it wasn't snapping onto the corner for them. Oh, make sure, I'm sorry, before you do that, click escape. Make sure you're in user comments. Whatever layer you're in, that's what it's gonna make it in, whatever you click, okay? So you can click the one corner and then click the other corner and then click again, and that third click allows you to move where the measurement is placed. Also, if you're still on the 1 inch grid size, that might be hard to do. So I recommend going to a smaller grid size again. So I used 0.01 inches. Because I see like you're stuck with the 1 inch. Oh, one. Oh, how many millimeters? 0.254. It doesn't matter. Just pick something smaller. Yeah, now you have a finer loop. Then you can put that, and then it's good. Make sure you snap on. And so your board is slightly bigger than that's perfectly okay. All right. Yep, and then do it for the do it for this side. The right. It doesn't matter. It's up to you. I'm gonna do the right side. There you go. And now you can see. Now you can always see the dimensions of your board. Yep. Okay. So once you have your actual board laid out, we can start actually laying out all our components. So I have a pre-made layout here already. You just click on the footprint, and then you can either click again to drag, or you can click the M key, which will allow you to move it. And then you just want to just find convenient spots on your board for all your components. Um, I'm gonna let you guys do that. Go ahead and organize it. I already have an idea of how I'm gonna organize it. Um, I'll I'll let you guys know when I'm done. uh, I'll try and I'll just kind of like give you tips along the way. If you guys have any questions about your layout or concerns, go ahead, just ask me. I'll come and help you guys. What do you mean the screen? Oh, here, yeah, that we'll do that after the layout. Make sure you, however you decide to organize it, just make sure you have space for this screen, okay? And keep in mind that this board looks pretty big, but when we actually make it, it's probably about the size of your palm. So that screen looks pretty big, but it's probably just barely big enough to fit your name in there, okay? Um, to help give an idea, my senior design board is about 50 by 60 millimeters. That's what that looks like. So ours is 76 by 50. So it's just a little bit taller. In fact, I might even think about making it a little bit bigger. Um, but that's pretty small, right? And so the silk screen that we're making is about this big. That might not be able to fit like a whole name. So I'm thinking, yeah, right. So maybe we'll make it a little bit bigger. We'll mess around with it though. If you guys want to look at this too. For you guys watching the recording, I'll wait till it's passed around and then I'll show it to you guys on I'll turn on the camera, I'll show it to you guys. I'm not sure how well you're gonna be able to see it though. Right? Yeah. Uh, not a lot. Two layers, yeah. Um, yeah, probably something, whatever the default thickness is. I manufactured that from JLC, and I had a size constraint, so this is going to fit in a case, so I couldn't make it any bigger than this. That's why we had the little cutout here, actually, for wires to go from the front to the back of the board in the case. So, yeah. Not the final design yet. Yeah. Then for those of you watching the recording, I'm gonna stop sharing my screen really quick. See how this looks. Okay, so here's the PCB. Okay, hold on. Yeah, yeah, I don't. I gotta turn it off. There we go. Okay, so here's my senior design. This is one of the test boards I printed out. Um, I'm just trying to give you guys an idea of the size of the board that we're making. This is about 50 by 60 millimeters. Um, so what we have set up right now is 76 by 50 millimeters. So although that silk screen looks really big on our board, it's only going to be like a little square right here. So during the next workshop, I might make that a little bit bigger so people can actually fit their whole names on it. I know some people have really long names. Or maybe you could do initials as well. I'm thinking that's what I'm going to do. So yeah, share screen. Okay. What? Oh, nice. Yeah. Would you like to borrow one? I have. Okay. Okay. Yep. Yep. You know what? I'm gonna go ahead and make the board bigger right now. Just delete these. I'll give you dimensions in just a second. Oh, 5, 3, 7. So you don't have to follow along with our design either. If you want to remake your board, that's cool. I kind of just give like little tidbits of information in the videos to help, and then the schematic is just if you want to follow along with something. Resistor. I'm just kind of just organizing the components here. Sometimes looking back at the schematic can help. So like R3, R6, R7, R9 all have LED connections. So it might be useful to know that because then I can put R3, R6, R7, R9 near the top here because the LEDs are going to all be around the name tag, right? Then I can go back. So and these white lines that are showing up, they're called a rat's nest, are helping trying to show you how the connections are supposed to be made. Okay. You can also, all these silk screen symbols, you want these to be legible and so like readable, so not overlapping with anything either. You'll get errors if silk screens overlapping, but you can click them without selecting the whole footprint, and you can move those around to somewhere where you can read it. One more thing that's useful, if you select a component from your PCB and then go back to the footprint, it will highlight the component you have selected as well. That can be helpful sometimes too. Another useful thing, if you're not sure what all the connections are, if you hold Control and then click one of the pads, it will highlight all the things it has to connect to complete the whole circuit. If you hold Control and then click again, that will make it go away. So sometimes that can help figure out where all your connections need to be. Don't do your ground connections yet. We're gonna do that last. Okay. And generally speaking, you want to do your ground connections last because you can usually make those connections by just creating a copper core or a copper plane, that a ground copper plane specifically. Welcome to the life from circuit design. So when you can't find your model, another option you have is to Google it. And then you can find one and download it rather than physically creating one. That should always be your first, um, your go-to, because although you may know how to make it, it's going to eat up a lot of your time. So, because you're going to have to look at the data sheet, you're going to have to look at the dimensions, the pad distance between each pad, how big the pad is there any through hole parts, all sorts of stuff. And it's gonna suck. So yeah, I'm just gonna try and get a reasonable layout here. One thing you may have noticed is that when I rotate my footprints, it rotates at a 45-degree angle. If you go, I believe by default it's 90 degrees. If you go to preferences, should be somewhere. Options, display options. Here we go. So go to editing options in the PCB editor. You can change the step for rotate. Um, by default, it's 90 degrees. 45 degrees is just, sometimes you might want your components at an angle. It might just fit better on your board. 367. So let's put. Okay, one more thing before you guys go. I don't know how much time you guys have. I know it's after. So I just wanted to show that when you have a bunch of components lined up here, um, it doesn't matter either if they're like kind of like jagged like this. You can select all of them by holding shift and then click each footprint. And then once you have them all selected, you can right click and go to align/distribute. And I can click distribute horizontally. So now all of these have an equal distance from each other. And then you can also click align to vertical center and it'll line them all up for you. That way you don't have to do that yourself. Sorry. Um, really quickly, just so you guys have this when we get to the next session, let's go ahead and just let's add the ground background or the ground plane. So in order to add a ground plane, you're gonna click on add a filled zone, and then you're gonna go to the corner of your PCB. Oh, I did it again. You need to make sure you're in either the front or back copper. It doesn't matter which, but you have to make sure you have the copper selected, and then go to that corner, and then this pop-up should come up. Let me know when you guys got that. Just one of the corners of the PCB. Yep, yep. Okay, and then we're gonna select back copper, which is BCU, and then ground. You can set different clearances. So this is the distance from like any of your traces or from the edge of the board. It'll make sure there's a clearance of no copper. And then you can change the minimum widths for your I'm actually not exactly sure what that is, but you can also set thermal reliefs, which are important, especially for through-hole components. If you do a solid layer of copper, it might become very difficult to solder your components onto the board because when you put the soldering iron, all the heat's going to be dissipating to that back copper plane. So you can create thermal reliefs instead, which um, essentially, instead of putting a solid layer of copper on the pad, it kind of looks like a cross pattern. You'll see it in a minute. And it reduces the amount of copper that's on that pad. And that's so that when you put the soldering iron onto the pad, it'll heat the pad up more than rather than the back copper plane. It'll help you get a good solder connection with your through hole components. So I really recommend using thermal reliefs with the default relief gap and spoke width should be fine. You can also change the outline display, which is just like physically how it looks. So whatever looks best to you, you can keep that. I'm gonna click OK. And then once you click OK, you should see this little line pop up. You should be able to place. So wherever you clicked is the starting point. And then you're gonna click on all four corners of the PCB. Here's that corner. And then you're gonna go all the way back to the corner you started and then click there. And it should look something like this. Should see this little hatch pattern or whatever pattern you picked. Yep, so click on the corner you started. There you go. You guys all have that? Okay, I'll wait for you. Sure, sure. I have them in the corners just for now. They're just gonna be on the four corners of the silk screen where you're gonna put your name. It should automatically put it in. Okay. I got like the last 10 minutes. See ya. All right. Now click. So right now there's no copper on the back of your board. Now, if you click B, that will fill the whole back part of the board with copper. This is generally, this will quicken how fast your board is produced because usually they have to shave off copper, and this makes their life easier. It's less copper to take off. You'll notice that if you go to all your ground connections, it'll have that crisscross pattern I was talking about. Those are your thermal reliefs on your pads. And we also won't have to connect those. Those rat nest lines for the grounds disappeared because now they're already connected to all the grounds because of the back plane. So this is usually really good too for limiting the amount of noise in your signals because it has to do with electromagnetism, how the electric fields are formed, but the ground plane stops from electric fields from other layers of your board getting and interfering with like top or bottom layers. That ground plane forces the electric field to terminate at that ground plane and reduces noise in your board. Okay. You'll notice that now when you move components, you're like, oh crap, well, the copper needs to move. So all you have to do is you click B again and it'll refill that spot, okay? And then I can control Z and put that back if I want. So since we don't have a lot of connections, I'm using the back layer just for all copper, and I'm gonna try and make all the connections for the front layer. One last thing I want to cover really quick, click on the drop down. You can go to edge cuts, and then we're going to create the little top part for the for a lanyard or for a I'm gonna make sure it's big enough to fit like a capo, not a capo. I've been calling it a capo all day. What is carabiner? A carabiner, so you can fit carabiners in it too. I can't believe I've been calling that a capo this whole time. So um I can click on the line here on the right and make sure you're in edge cuts. And then if I already have it terminated, I can click escape. And so that'll just make the one line. And then I want to line up another one about like right here and line that up the best I can. And then click escape. So now I got two parallel lines. And then I want you to click on not the circle, but this one, draw an arc. So what I can do is I can go to the center between these two lines. I can make a circle and then I can control how much of the circle I want. I actually want to start here. No. So the way it starts is positive negative degrees. So if I want wherever I click the second time is going to be the starting point for drawing the arc in the negative direction. So I'm going to click here and then it'll let me draw that way. And that just gives you a really nice edge rather than something like rectangular. There we go. And then, of course, that's going to be cut out. So we're going to refill the copper in the black plane. So click B again and get used to that. So now that little hole is going to be cut out. So we put lanyards and other things. And then I think that's all we're gonna cover today because we're already past the time. Um, we'll add the silk screen, and I'm gonna reposition these LEDs a bit, just to make them lined up and look nicer. But I think this is the layout we're gonna stick with here. We'll move some of the silk screens around next time, and then hopefully by the end of that, we can start looking into printing, manufacturing our board. So thank you guys for attending the workshop. Thank you for anybody watching this video. I'll see you guys next Wednesday. All right, have a great day. See you guys in the next one.